Okay, Pedro, here's the problem you sent me in text messages. I didn't get copied down here that they're talking about this when n is greater than m, but that doesn't have to be the case. M could be greater than n. But I wanted to draw your attention to the fact that your book has a typo because this expression right here, those are powers with the same base. If you multiply those together, b to the m times b to the n minus m is equal to b to the nth. This should be an n right here. And then the nth root of b to the n is b. So that's a typo. Okay, but to talk, before we get into what all this actually means, let's just make sure you're aware of this. If you take the square root of 2 times the square root of 2, you get 2. Because 2 times 2, the square root of 2 times the square root of 2 is the same as the square root of 4. The square root of 4 is 2. Another way to think of radical 2 is in exponential form is 2 to the 1/2 times 2 to the 1/2. And now when you're multiplying powers with the same base, you add the exponents. So 2 to the 1/2 times 2 to the 1/2 is 2 to the 1st. So to talk about rationalizing the denominator, let's start with a very simple one. Let's say I had 1 over the square root of 2. In the old days before calculators, we used to rationalize denominators so that we could find out a decimal approximation for this expression. To do this right now, if you know that the square root of 2 is approximately 1.414, which it is, to evaluate this, you'd have to do 1.414 divided into 1.0000. And I don't know about you, but I don't want to do that calculation. Forget it. So in the old days, that's one of the reasons we used to rationalize this denominator. Well, how do we do that? Multiply top and bottom of this fraction by radical 2 over radical 2. I'm multiplying by the number 1, so I'm not changing the value. I'm just going to change the way it looks. What do I get? 1 times radical 2 is radical 2. And radical 2 times radical 2 is 2. So these two expressions have the same value, but they look different. And this one's much easier to get a decimal approximation for. 2 divided into 1.414, I can almost do that in my head. 707. So the decimal approximation for 1 over the square root of 2 is 0.707. That's the primary reason that we used to rationalize denominators. So now it's just an accepted thing to do. Let's do one more of those. Let's say I have 2 over the square root of 3. And I want to rationalize. I pick radical 3 times over radical 3 because when I multiply radical 3 times radical 3, if I picture this in exponential form, the exponents are going to add up to 1. 3 to the 1/2 times 3 to the 1/2. And so in effect, I've gotten rid of not only the exponent, but the radical in the denominator. I've rationalized the denominator. There's no fractional exponent. So if I have a problem like, 5 over the 5th root of 2 to the third, like this. The question is, what do I have to multiply top and bottom by so that I don't have a fractional exponent anymore in the denominator? And this is much easier to see if you put the fraction or the radical in exponential form. So this is the same as 2 to the 3/5. Now what do I have to multiply this fraction by so that I end up, when I add the exponents, with 2 to the first? Well, I just subtract 3/5 from 1 and I get 2/5. So I multiply by 2 to the 2/5, or the 5th root of 2 squared. The whole point is that this becomes the 5th root of 2 squared, or 4 if you want. And in the denominator, I get 2 to the first, or 2. So I've rationalized the denominator. And if you go to Desmos and type these two expressions in, you'll get the same decimal approximation. Okay, so what are they saying over here? What is this b to the n minus m? All they're saying is this is like the n right here, and this is like the m. So 2 to the 3/5 times, by subtracting 5 minus 3, I get 5 minus 3 is 2. That's kind of how I figure out what I have to multiply by. So that's all this is multiplying these two powers together so that when you add the exponents, you end up getting the nth root of b to the nth, which is just b. For me, I would never think of it this way. I would always convert to a fractional exponent, subtract the original exponent from 1, and that will tell me what I have to multiply by. So let's do one more using letters. Let's say I have x over the 6th root of y to the 2nd, and I want to rationalize that denominator. After you do a few of these, you can see what you're multiplying by. This is the same as y to the 2/6, or 1/3 actually. So what do I have to multiply by so that I end up with a 1 for the exponent? 2/3. Y to the 2/3. So that's x cube root of y squared over y to the first. So I've rationalized the denominator. And according to your little rule on the previous page, I multiply by the 6th root of y to the 4th, n minus m. n minus m is 4. That's your multiplier, which is y to the 4/6, which is y to the 2/3, which is what I multiplied by. Okay. I'll leave you with that. If we need more clarification, we can talk about it at our next session. Or let me know if you need a little bit more clarification.